Students, good morning, Vishnu. Welcome you all in your very own faculty driven institute, Resultant. Hope you guys are fine. So, guys, be quick and join the session fast. Good morning, guys. Good morning. Okay, so we'll start with the session quickly without wasting time. And, guys, this is the first mini mock test. That is, today is Wednesday, right? So, you'll be having the second mock test on Friday as well. Now, let's start the session quickly. First of all, guys, welcome back again. And guys, if you're new to this channel of AEJ, then kindly subscribe it, share it with your friends, and like the session as well. Apart from that, if you don't know about me, then you can go through my profile. Next, guys, we are having next. We are having what? We are having Maths Booster by Ankit Joshi, sir. So a complete course on engineering mathematics for GATE is there by sir. MRP price is 4,999, but guys, right now the offer is going on. You can get it for 2,499, and entire syllabus will be covered for engineering mathematics. Classes will be Monday to Friday, so like weekends you can chill and enjoy as well. Timing will be from 9:15 to 11. Okay, or 11:15, that depends. So if you have any doubts, you can call on the number 79913104116. Okay, apart from that, now let's move further. So this is our RRB JE Civil 2024 team. Apart from that, guys, we have launched paid batches for CBT1, that is focus batch. Right now, the offer price is 2,499. We have CBT2 aim batch. The offer price is 3,999, and CBT1 and CBT2 mission batch, and the offer price is 5,499. Okay, so you guys can check it out. You guys can check it out in our app. You can download Resultant Civil, Resultant Mechanical app from the Play Store. And if you have any doubts, you are free to call us. Okay. Now let's start with the sessions. But before that, guys, what you will be getting if it is a non-tech batch of CBT1, here 200 hours of class, PYQs, quiz, doubt session, test series will be provided to you. Technical civil, it will be a 400 hours of class, PYQs, quiz, test series, doubt session will be there. And CBT1 and CBT2 live plus recorded classes, PYQs, quiz, test series, doubt sessions will be there. Okay, that is 200 plus 400, that is 600 hours of class. Okay, now let's start the session quickly. This is the first question for you guys. Be quick. The peak factor for estimating maximum hourly demand relative to maximum daily demand. This is a question which is very, you can say, popular, been asked a number of times. Quick, come on, guys. Answer. The peak factor for estimating maximum hourly demand relative to maximum daily demand. Wrong, wrong. Check it out, Vishnu. It is asking you what? Maximum hourly demand relative to maximum daily demand. Maximum hourly demand of maximum day is equal to 1.5 times what? 1.5 times average hourly demand. Average hourly demand of maximum day. Now, what it is asking, the peak factor for estimating maximum hourly demand relative to maximum daily demand they have mentioned. Now, this is an ambiguity. They have written maximum average hourly demand of maximum day. So, you could take 1.5 also. 1.8, 1.8 is maximum daily demand is 1.8 times annual average daily demand. So, 1.8 will not be there for sure. So, that will get cancelled out. 2 is not there, they are gone. Now tell me 1.5 or 2.7. 1.5 or 2.7. Come on, guys. 1.5 or 2.7. See, When you write like this, maximum hourly demand, this is 1.5, and this will become maximum daily demand by 24. Okay, so you can write it as 1.8 times annual average daily demand by 24. So this comes 1.5 into 1.8 is 2.7, and this will be annual average hourly demand. So maximum hourly demand is 2.7 times annual average hourly demand. In the question, it is asking you maximum hourly demand related to maximum daily demand. So this will be 1.5. 1.5. Got the logic? I told you the entire concept of it. Excuse me. Now, next question. Question number 2. Population forecast, that means predicting. For determining, see, when you do daily by 24, 1.5 into 1.8 is 2.7. And when you do daily by 24, what you will get? You will get hourly, because one day is equal to 24 hours, and you have divided 24 hours of water demand by the number of hours, that is 24. So you will get annual average hourly demand. Okay, annual average hourly demand. Clear? Now, next question. Got it? Is it clear? Now is it clear? Vishnu, everybody else, is it clear now, beta? Okay. Next question. Population forecast for determining future water demand. So what do you use for forecasting future water demand? Future water demand. Come on, guys. Future water demand. See, you can go for arithmetic increase, but that is generally used for large cities or old cities, or where rate of growth of population with respect to time is constant. Okay, but the one for determining future water demand is, see, everything can be there, but this word is written best judged by. Best judged by. So it is best judged by geometrical increase method. Okay, because generally for rapidly growing cities, for young cities, we use it, and here we assume percentage rate of growth of population with time is constant. This is known as geometric increase method. Okay, now next, no, graphically by comparison with similar town, you can do that, but then we could have called it as comparative graphical method, but here future water population, we go for geometric increase. However, C option can be also correct. This question is incomplete. They should have written, mentioned the type of city, like old cities, rapidly growing cities, new cities. They should have mentioned that. So that this question is not incomplete. But sometimes you get these type of questions also in the examinations. Okay. Now this is a new question for you guys. Which of these parameters does not influence the design of a harbor? Come on, does not influence. Does not influence the design of a harbor. Which one? Quick, guys. कोशिश, try once. Which of the parameters does not influence the design of a harbor? Which one? Very good. Rainfall doesn't have that influence whenever you're designing the harbors. Rainfall does not have any influence on the designing of it. So rainfall is the answer. Correct. Question number 4. On standard silica scale, the turbidity in drinking water shall be limited to. You know that we have STU, silica turbidity unit. 1 STU is equal to 1 ppm is equal to 1 mg per liter. Okay, so what should be the turbidity in drinking water? Come on, quickly tell me, I'm waiting. Shall be limited to 5 ppm. Generally we say 5 NTU. Okay, in the old books and all, if you check it out, in the old version, means the code which we follow is IS 10500 2012, but in 2015, 16, 17, a lot of amendments has been there. Okay, so now if you talk it about 1 NTU is the acceptable limit and 5 NTU is the cause for rejection limit. So generally here we will go for 5 ppm. If you check out the books, in the old books, they will mention it as 10 ppm. That was as per the old codal provisions. As per the new codal provisions, it is 5 ppm. Okay, so remember this. Fine. Got the answer for this. Now, question number 5. Now, this is a very easy question. I will not answer. It is asking you threshold odor number. TON, it is asking you. Come on, guys. Kindly write the question number for which you are answering. Okay, in that. Come on. When 50 ml of water is diluted and is made 250 ml. Come on. 50 ml of water is diluted. So how much is the raw water or sewage, whatever? It is 50 ml. And you added water. How much? They haven't told you directly, but told you that when you added water, the diluted one, because you know dilution means what? When you're adding water. Like you have that concentrated acid and dilute acid. Dilute is that acid in which you have water present in it in a significant quantity. If you talk about concentrated, can you touch it? And even if it falls in your skin, you just burn it. Okay, it will burn it. So like we place it at a distance and with glass rods we pour it. Why? Because it doesn't have water or very negligible quantity of water. It is highly concentrated. But dilute, you can just take out the beaker and you pour it into your test tubes because it has significant quantity of water in it. Similarly here. Okay, so A plus B they have given to you 250 ml. What is threshold odor number? A plus B by A. So this will be 250 by 50, that is 5. How come 6? Check it out. I think you have done the wrong thing. Now let me tell you. The wrong thing which you guys, this is an English thing which will be happening. What you guys will be doing is, you will think that 250 ml is the raw water, means the water which you have added, the fresh water, distilled water, pure water, anything you can guess, and this. And Vishnu, you would have done this. 250 plus 50 divided by 50. So 300 by 50 and you got 6, which is wrong. Why? Because check it out, the wordings of it. When 50 ml of water is diluted, now you are adding water and is made 250 ml. That means that 50 ml is made 250 ml. That means it will include water also in it. So A plus B will be 250 ml. Got it? So and is made 250 ml. Clear? Understood now? Got the concept? Or they could say and is, or the different words which they use, when 50 ml of water is diluted till the concentration is 250 ml, then also it will be A plus B. Okay? Now, question number 6. Fine. Do match the following. Come on, guys. Do the match the following. Quick. Got it now? It's good, make mistake here so that you don't make mistake in the exam. That's what I always say. Final? Let's check it out. Alkalinity we measure with the help of what? We measure with the help of 0.02 normal H2SO4, because alkalinity is the ability of the water to neutralize acid. So A is 3. Hardness we go for what? EDTA, ethylene diamine tetraacetic acid. So this will be 4. Chloride if I talk about is silver nitrate, AgNO3. Dissolved oxygen if I talk it about is sodium thiosulfate, Na2S2O3. So 3, 4, 1, 2. This will be B option. Why D? Why D? Alkalinity is like, alkalinity is what? Ability of water to neutralize acid. So obviously when you are titrating to find alkalinity, we will be using acid, and generally we go for sulfuric acid. Of course you can go for other acids, but generally we prefer sulfuric acid. Okay, hardness you know it, that was patent. How can you make mistake in hardness? Hardness is EDTA, ethylene diamine tetraacetic acid. Okay, fine. Now, question number 7. 5 days BOD is given to you, deoxygenation constant is given to you. It is asking you ultimate BOD. Come on, answer ultimate BOD. Now, such questions you will say, ma'am, if like let us suppose, I'll tell you, you will say that, ma'am, if let us suppose I used BOD 5 days is equal to BOD ultimate 1 minus E minus KT. Okay, so this using it, it will require calculator, but you don't have calculator. So don't go by this logic. Now go by that logic that 5 days BOD is 0.68 times of BOD ultimate. Go by this logic. Okay, so 5 days BOD is what? 160 mm. 0.68 BOD ultimate. Or you can write 2. If you find difficulty in doing that 0.68, you can go by 2 by 3 1 also, like this. So 2 ones are 2, 2 8s are 16, approximately 240, near to that it will come. So this will be 234. See, it will be 80 into, this will be 8 ones are 8 2 is 16, 8. This is BOD ultimate. This is approximate. So the answer which is close to it will be 234. So guys, if such question comes, don't say that, ma'am, they haven't provided the calculator, so we were not able to do. Go by this logic and you will be able to do. Go by this logic. Clear? Okay. Question number 8. A wastewater sample of 2 ml is made up to 300 ml. Now check it out again, Vishnu. A 202 ml of wastewater sample. So the wastewater sample, let me call it as volume of sewage. Okay, I'll write VS. This is 2 ml is made up to 300 ml. Is made up to, that means volume of sewage plus volume of water is 300 ml. Okay, initial DO is given to you as, initial DO is 8 mg per liter, and after 5 days it is 2 mg per liter. Now it is asking you BOD value. Come on. Hi Sandbook, I'm good. How are you? Come on, answer. 5 days BOD. Nothing mentioned. Generally, we have the habit of taking 5 days 20 degrees Celsius. Come on, tell me. Quick, guys. DO initial minus DO final into dilution factor. Correct? Initial DO is given 8 mg per liter. Final DO is 2 mg per liter. And dilution factor is what? Volume of sewage plus volume of water upon volume of sewage. Okay. So this is 300 by 2, 150. So 6 into 150, this will give me 900. Simple. Got it? Clear? Okay. Now, 10 questions from each topic. Now this question. Select the correct sequence of the treatment of methods which are given to treat raw water supply. Come on, guys. Technically, none of this is correct. Nobody is correct. The logic which we follow is none of this should be the option. First, we go for screening, then aeration, then coagulation. How can you do sedimentation, then coagulation? The coagulation, then you go for flocculation, then you go for sedimentation, then you will go for filtration, and then you will go for disinfection. It is partly correct, but how can you first do sedimentation and then coagulation? This word should not be there. Then your option A will be correct. If coagulation, because if you're doing, first of all, coagulation will happen before sedimentation. Secondly, if you're doing coagulation after that, you have to do flocculation, slow mixing. So technically, if you'll ask me, this is the generalized one. And here, if coagulation would not have been mentioned, A would have been the correct. Okay, fine. Now, question 10. Higher turbidity in water supply is objectionable. We don't want higher turbidity. Turbidity is due to the presence of suspended solids. Higher turbidity is objectionable. Why? Reason. Come on, guys. Objectionable is not required. That's why we have acceptable limit 1 NTU and cause for rejection limit 5 NTU. Why? Come on, basic answer is there. Why higher turbidity is objectionable, guys? Come on. Anybody? See, if higher turbidity will be there, that means suspended solids will be there. Suspended solids take place why? Due to suspended solids, the source is from organic matter. So what will happen? If higher suspended solids are there, that means higher turbidity, and that will lead to the growth of bacteria in the distribution system. Okay, so it encourages after growth of bacteria, and we have done disinfection, so we don't want that bacteria and all should be there. But if larger amount of suspended solids will be there, growth of bacteria will be there. So it encourages after growth of bacteria in distribution system. Okay, now next, come on. Now question from survey. Now 1 centimeter on our map represent 10 meter on the ground. What will be the representative fraction? Representative fraction means RF. Come on, guys. Representative fraction means RF. Come on. What is this? Map distance upon ground distance. Map distance is 1 centimeter and this is 10 meter. Converting meter into centimeter, 100. So this will be 1 upon 1000. C will be the answer. Okay. Question number 12. This is very simple. Plane scale is used to measure how many dimensions, guys? A plane scale is used to read how many dimensions? Quick. Plane scale. Just one dimensions. Plane scale just along the length it will measure. So plane scale is used to measure only one dimension. Very simple. Sometimes we are so much into tougher questions that simple question doesn't strike to your heads. So you need to practice. How come two dimensions? How come two dimensions? Okay. How come two dimensions? I know. That's why I was like Vishnu is awake or not. But tell me how come two dimensions? You are correct. But tell me the logic. See, if you check out the scale only, you will have meters in it and you have five bifurcations. Like if you talk it about here, you have here one, two, and then you have multiple bifurcations here also, right? So here you can like if it is coming here and this also. So it will measure meter also and it will measure centimeter also. Or if it is a small scale, it will measure centimeter also and it will measure also. So technically, if you look at the broader sense, you will say, oh, it is measuring length. But if you bifurcate it further, like meter centimeter or centimeter you are getting, so it will measure two dimensions. Clear? I asked you the reason, you haven't replied, Vishnu. Okay, so this is the two dimensions. Okay, 30. Reconian survey for determining feasibility and estimation of schemes falls under the classification based on, so preliminary surveys which you do it falls under which thing, under the classification based on what? Come on. Reconian survey for determining feasibility and estimation of scheme falls under the classification based on. Come on, guys. What? See, on the basis of it, we classify as that engineering survey, Reconian survey. So, on the under the classification based on object of surveying, क्या object है, किसके लिए आप surveying कर रहे हो? What is the object? What is the aim? Okay, based on that you have engineering survey, based on that you have military survey, Reconian survey, different surveys are there. Okay, question number 14. This is a very common question asked in the examination. Spire test is used for the adjustment of. So where you use it? Spire test is used for the adjustment of. Come on guys, this is a very patent question. Spire test is used for the adjustment of guys, 20 seconds, is used for the adjustment of horizontal axis. Okay, so you're using spire test for the adjustment of what? Horizontal axis. Simple. Okay, now 15th. Determination of the size of the theodolite is specified by. So when you are specifying the size of the theodolite, by which thing you specify? By the upper plate, lower plate, length of the telescope, or the diameter of the vertical circle? How do you determine the size of the theodolite? Horizontal axis, not vertical axis, Vishnu. Question number 15. Size of the theodolite. Survey you need to study, because from survey also you'll be getting the question. So determination of the size of the theodolite is measured by the diameter of the lower plate. नीचे वाली plate के diameter से. So it will be the diameter of the lower plate. Now, question number 16. Two theodolite method of setting out a curve. So what are the things which are involved if you are taking out two theodolite method? Come on, setting out single curve. दिमाग होगा टू theodolite है, so linear and angular both should be there. If you haven't studied anything, you will think in this manner. But if you have studied, then you will give the answer that two theodolite method of setting out a curve involves angular measurements only. Okay, it will involve only angular measurements. Correct? Okay. Question number 17. Reiteration method. So what is the other name of reiteration method, guys? By what you call the other name of reiteration method? पक्का? Mhm. Firstly, reiteration method is used for what? It is used for measuring horizontal angles. You can call it method of series or direction method. Both the options are correct. Okay, you told me the incorrect one. Reiteration method. This is accurate, precise, less tedious, used for the measurement of horizontal angles, and you can call it as method of series or direction method. Anything. Okay. Now, question number 18. Now, this is very easy question. The total energy line, which is TEL, is always higher than HGL, that is hydraulic gradient line. What is the difference between both of them? Come on, guys. If you check it out, this is datum head, this is pressure head, and this is kinetic head. This line will give you hydraulic gradient line, and this will give you total energy line. So the vertical distance between the two will be v square by 2g, that is the velocity head. So the difference, or you can say the distance between the two will be how much? V square by 2g, which is the kinetic head or the velocity head. Anything you can say. I'll write down the other name of it. Kinetic head. Correct. Very good, Vishnu. Okay. 19th. A venturimeter is a device used for measuring. So why do we use venturimeter? Why do we use venturimeter? Come on, guys, venturimeter. If you don't know, then what will I do then? Venturimeter is a device used for measuring what? Q, rate of flow of fluid which is flowing through the pipe. So this will be what? C, rate of flow of fluid through the pipe. Got it? Simple? Correct. Correct, Vishnu. 20. Now, just now we have discussed hydraulic gradient line represents the sum of. Just now we have discussed HGL. Hydraulic gradient line represents the sum of. Come on, answer. Hydraulic gradient line. Just check it out. Hydraulic gradient line represents the summation of Z was datum head and P by gamma was pressure head. So it represents the sum of datum head and pressure head. Datum bed, it is written by mistake. Datum head. And this is for the total energy line. Got it? Total, datum head also, pressure head also, kinetic head also. Simple. Now, question number 21. Under which of the following conditions do stationary shock waves occur? Stationary shock waves occur. In which of the following conditions, guys? Come on. Stationary shock waves. Excuse me. Stationary shock waves. When do you get it? Now, this is a new type of questions, I guess, which you are getting. Stationary shock waves. Mhm. Partially correct. Two streams are there. They have the same value of flow, but they are having different densities and they are meeting. So when two streams having same flow value but different densities meet, that time you call it as what? What they will produce? They will produce the stationary shock waves. Okay, when two streams having same flow value but different densities, they will do what? They'll produce the shock waves. Okay, this one. Reynolds number greater than 2000. I'm talking about for the case of open channel flow. I'm talking about the case of open channel flow, guys. Come on, answer. Flow. Acha, in the previous question you were asking discharge per unit time, flow value, or you can say flow rate, Q. That is flow value. Simple. We are not going for that highway one flow value. Okay. Not going for that one. Okay, this is turbulent. Correct. Reynolds number less than 500, laminar, greater than 2000, turbulent, and 500 to 2000, it is transitional. So here it is greater than 2000. So this will be what? Turbulent. Okay. Question number 23. This directly you will see it and you will answer. A channel which is a trapezoidal section, it will have maximum discharge when? Technically, it is asking you most efficient trapezoidal channel section. Come on. Most efficient trapezoidal channel section. डीप कंसेप्ट को स्ट्रॉन्ग कैसे बनाऊं? Conceptual theoretical questions है ना, like अभी shock waves one we have done, then other conceptual questions उसको ज़्यादा से ज़्यादा practice करो. Like shock waves you are not knowing, now you will go back to the topic of shock waves and you study it. So when you practice this questions, see, क्योंकि आपको शायद पता नहीं होगा that whatever concepts you have studied आपको कितना clear है कि नहीं, पर जब आप क्वेश्चन करोगे आपको समझ में आ जाएगा कि आपको वो concept clear है कि नहीं. अब समझ में आ गया कि नहीं बन रहा है वो चीज़, वापस जाओ पढ़ो उस चीज़ को. ठीक है. अब जैसे बाय चांस लेट अस सपोज अब आपको यहाँ दिस क्वेश्चन इज रिलेटेड टू मोस्ट एफिशिएंट ट्रेपेजॉइडल चैनल सेक्शन, अब आपको पता ही नहीं है ये क्या है, देन गो बैक देयर, study the most efficient channel sections, rectangular, trapezoidal, circular, triangle, and then come back again. इसी तरीके से आप उसको strong कर सकते हो if you have already studied the entire subject once. और अगर अभी पहली बार पढ़ रहे हो तो फिर तो ज्यादा अच्छे से पढ़ो पहली बार में ही. ठीक है. Half of top width is equal to the length of side slope. अब यहाँ पे क्या हो जाएगा, इसके हिसाब से क्या होगा, हाफ ऑफ टॉप विड्थ इज इक्वल टू स्लोपिंग साइड. अब देखो यहाँ पे गलती कर दी ना विष्णु, सी यू हैव मेड अ मिस्टेक. Check it out. Trapezoidal channel section. If the top width is T, so half of top width. Excuse me. Half of top width is equal to the length of the slide slope, whatever is the value here. Okay, so see, half of top width is equal to sloping side. Sloping side means length of the side slope. D is the correct answer. Okay, so you should remember this. How much should be the angle here? It should be how much? Internal angle should be how much? This should be 60°. This is 120°. And if they ask you questions like most efficient trapezoidal channel section is half of regular hexagon, yes, it is true. Why? Because internal angle, this is 120°, this is 120°. So it is half of hexagon. Check it out. So all these statement things which they have mentioned to you, you will be able to know it when you have gone through the concepts of trapezoidal channel section. What is the value of M? All those things you should know. Then only you will be able to solve it. Okay. Like if I take O as center and depth of flow as radius, and if I draw a circle, it will touch all the sides tangentially. So these basic things you should know. Got it? Now, 24th question. Sediment size is given to you 0.81 mm. Now you have to calculate the silt factor. Come on. Calculate the silt factor. Quick, 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 guys. Silt factor. The simple. You practice, Vishnu, you'll be able to do it. Have that confidence, you will be able to do it. Definitely. If you have studied with the whole syllabus perfectly, precisely, then practice and practice. That's the only thing. Okay. Now here, silt factor F is equal to 1.76 root D in mm. This is 1.76.81. You can write it as 1.76 81 by 100. So this will be, how much it will come? Yes. Solve it, how much it will come? 1.5 something. So we will take D. Okay. Question number 25. Lining of canal is necessary. We provide cement, concrete lining, vitrified clay lining. So what is the reason of providing lining, guys? For what reason do we provide lining? Come on. Cement, concrete lining, boulder lining, vitrified clay linings, and different types of lining is there. Why do we provide lining? You provide it along the whole wetted perimeter, so that scouring doesn't take place. That is, the erosion of the particles doesn't take place. Correct? Seepage losses should be minimized. Okay, because 25 to 50% losses can take place due to seepage. Okay, and how does seepage happens? When the water, see, water you cannot restrain it, it is flowing. So whenever the water finds energy, whenever the water moves from higher energy to lower energy, the movement you call it as seepage. It moves through the interconnecting voids of the soil particles. Okay, and what happens, since it is not letting any scouring erosion to happen, and it is reducing the losses, so obviously what will happen, the discharge will be increasing. Okay, and the velocity, like discharge is equal to area into velocity. Now area is fixed, no distortion, nothing is happening because you have provided the lining. So what if you want to increase the discharge? How can you increase it? By increasing the velocity. Simple. But nothing will happen to the area. Why? Because you have provided a proper lining, so nothing will happen to it. Okay, now, so this is all of the above. All three are correct. Question number 26. Garrett's diagram are used for graphical solution. Now this is a question which has been asked. This question is quite popular, guys. Garrett diagram are used for graphical solution of design equations of a canal by. This is a very common question. Kennedy's theory. Where do you use this Garrett's diagram? Garrett's diagram, we use it for Kennedy's theory. And one more I'm telling you, if they would have given two options and last they would have written both A and B. Cutter's equation and Kennedy's theory. For both we go for Garrett's diagram. Okay, so these are the diagrams with the help of which we are able to calculate the values. So here as it is given, so only Kennedy's theory will be the answer. Okay, 27th. For a discharge of 64 Qmax and silt factor, silt factor mentioned nahi hai. Look, I'll check out this question. Solve this. What is the cross-sectional area of a regime channel? Discharge is 50 meter cube per second and silt factor is given to you as 1.1. Directly formula based question, guys. Direct formula based question. Come on, solve it. I check out that question till then. 0.6. Right. Solve this. See, if you want to calculate area, area is equal to discharge is equal to area into velocity. From here, area will come discharge by velocity. Correct? Discharge is 50 meter cube per second. Velocity you need to calculate. Velocity, how will you get it? Qf square upon 140 to the power 1 by 6. This is the formula. 50 into silt factor is 1.1 square upon 140 to the power 1 by 6. This will give you the velocity. How much it will come? I am using calculators because I am not that good right now in manual calculations. 0.869 meter per second. So 0.869, 57.5 meter. So B will be your answer. So here this formula you should know. Important. Okay. Now this question, for a discharge of 64 Qmax and silt factor of zero point 0.6. What is the normal regime scout depth? Now again this is a formula based question. Come on. Normal regime, some people call it as regime, some people call it as regime. The normal regime scout depth. See here only they have given you Q. They haven't given you discharge per unit concept. Okay. So what formula you have to use? You have to be very, very like cautious about it. Come on guys. The normal regime scout depth. The formula you should know. You don't remember the formula? There are two formulas. 1.35. This formula is there. Q square by F by power. This you use it when discharge per unit width is given. Here they have just given you the discharge and the silt factor. So here 0.47 Q by F to the power 1 by 3. This is the formula of normal regime scout depth. Now come on, at least substitute the value and tell me how much it is coming. 0.47 64 by zero point 0.6 to the power 1 by 3. Two point 228 it is coming. So approximately it is near to A option. Okay, simple. So remember, there are two formulas. One is this formula and one is this formula. If in the question they would have given you discharge per unit width, you would have used this. Or if in the question they say very wide something rectangular channels, then you go for this one. Okay. Now question number 29. This question has been asked in many examinations. If siphon aqueduct is given to you, what is the most severe condition? Siphon aqueduct is what? It is just the opposite of aqueduct. What will happen is just the opposite of aqueduct in a sense. In a sense is, firstly the canal, as an aqueduct is there, the canal will be at the top and the drain will be at the bottom. So it's same in that way, but slightly different is here the canal bed level will be below as compared to the flood level of the drain. Come on. When it will happen? Canal is above, drain is below. The canal bed level is below as compared to the high flood level of the drain. So when is the condition? This is an important question asked in GATE, asked in other competitive examinations as well. Come on guys. What is the condition? See, when the canal is dry, agar canal dry hua means there is no water in the canal, that means there is no weight of the water which is acting in vertically downward direction, correct? But the river or the stream is flowing below the canal. So if let us suppose this is the canal, okay, no water is there above it, and the drain is flowing and the level of water in the drain is above, this is, if this is the canal bed level, the level of water of the stream or the drainage is above this canal bed level. So this will exert uplift pressure. You're getting it like this. This will exert uplift pressure. Okay. So what will happen is, oh, failure of this canal will take place. Okay. So canal is dry and drain is passing the highest flood. That means drain is at the high flood level. So this is the condition you will be getting. Why? Because if, see, if the canal would have the water, it would have exerted it in the vertically downward direction. Okay, but since no water is there in the canal, no one is exerting pressure in the vertically downward direction, and the drain is doing what? It is exerting pressure like this, uplift. Okay, uplift pressure. So this becomes the severe condition. Okay. Question 13. Which one of the following filters will produce water of high bacteriological quality? Come on. This is a very patent question asked in the examination, guys. Come on, guys. Bacteriological quality. Slow sand filter, 98 to 99% it can remove all the bacteria which is present in water. In rural areas we go for it. In urban areas we don't go for slow sand filters because rate of filtration is less, provided it requires more area, 100 to 2000 square meter. Clear? So that is the reason we don't go. However, since here you do cleaning in an interval of 1 to 3 months, so the thickness of the smart stack layer will be there, which will be efficient, because I told you biological things takes time to happen. You were also born after 9 months, right? So similarly, if you want the microorganisms to grow, and they should do what? They should decompose the organic matter, and then endogenous respiration should take place. The microorganism should kill itself on its own. So for all those things it takes time. Slow sand filter, you do the cleaning from 1 to 3 months span, you do it. So what will happen is, here the thickness will be more, the microorganisms growth will be rapid, and it will be in a significant quantity. So here you will be getting what? You will be getting removal of 98 to 99% removal of bacteria. So first they will be growing, they will decompose the organic matter, and when bacteria will not get food, they will do endogenous respiration. That means they will kill themselves on their own. Okay, that is what they do it. Okay, that is known as endogenous respiration. Okay, last two question. The question is from hydrology. The rainfall in 5 successive days on a catchment is given to you. Phi index is given to you. It is asking you direct runoff. Very easy question. First 30 seconds you will solve it. Quick. Quickly solve it. Quick, quick, quick. 5 successive days they have given you. Phi index they have given you. Phi index is what? Average infiltration rate above which rainfall volume is equal to runoff volume. अगर मैं हिंदी में बोलूं, phi index सिर्फ उसी rainfall को consider करता है जो आपको runoff produce करके देगा. ठीक है. 3 centimeter rainfall took place and 3 centimeter got infiltrated. Will you get any runoff? No. 5 centimeter rainfall, 5 meter rainfall took place. Now this is in meter, this is in centimeter. This also has to be in centimeters. Meters अगर rainfall होगी तो सभी डूब जाएंगे. 3 meters, imagine. Okay. So out of 5 centimeter rainfall is happening, 3 centimeter infiltrated. So rest one will be flowing. Okay. 9 centimeter rainfall took place, 3 centimeter infiltrated. Okay, 6 centimeter rainfall took place, 3 centimeter infiltrated. 1 centimeter rainfall took place, which is less than the infiltration, so no runoff. 5 minus 3, 2. 9 minus 3, 6. 6 minus 3, 3. 6 plus 3, 9. 9 plus 2, 11. 11 centimeter. Got it? Clear? So this is the logic which I have applied. You can go by this logic also. This is 3 centimeter per day. I will take only those precipitation which produced runoff. Which is the one precipitations I will take is 5 plus 9 plus 6 because they produced a precipitation. 3 and 1 hasn't produced precipitation, hasn't produced any runoff. Okay, minus runoff, and we will take only that duration which has produced runoff. This is 3. So 3 3s are 9. 5 plus 9 plus 6 minus runoff. 9 9 will get cancelled out. From here also you will get 11 centimeter. So either you can go by this concept, then also you'll get the same answer. You go by this concept, then also you'll get the same answer. Clear? Okay. Last question. A unit hydrograph has 1 unit of what? Unit means 1. But 1 unit of what? A unit hydrograph has 1 unit of what, guys? If I draw it, I say this is 1 centimeter. So what is this 1 centimeter when I talk about unit hydrograph? Come on. Where? Here? Here you're talking about denominator. This phi index 3 was given in the question. If you're asking this 3, I will take that duration only which produced rainfall axis. This 3 centimeter was not greater than 3 centimeter per day phi index, so I will not take this. This is first day, second day, third day, fourth day, fifth day. This is the time in days. Excuse me. I haven't took these two values. Why? Because here whatever precipitation was there, it was not producing runoff. So how many precipitations was producing? 5, 9, 6. So this is PE. Okay. And for how many days? 1 day, 2 day, 3 day. So that's why this 3 day. I will take only that duration which produced runoff. So precipitation also that, and number of days of the time also that. So that's why I took 3 days here. Got it, Vishnu? Clear? Okay. Last question. A unit hydrograph has 1 unit of what, guys? 1 unit of, you can draw triangle, trapezoidal, any shape. 1 unit of rainfall axis. This is N, which is 1 centimeter. So 1 unit of rainfall axis. रेनफॉल एक्सेस मतलब वो रेनफॉल जिसने रन ऑफ प्रोड्यूस करके दिया. यू कैन कॉल इट एज रेनफॉल एक्सेस, यू कैन कॉल इट एज इफेक्टिव रेनफॉल, यू कैन कॉल इट एज एक्सेस रेनफॉल. All the three means the same thing. Okay, so these were the questions, guys, from my side for today's session. Now tomorrow we will be having a session of quantitative aptitude, profit and loss, all those questions, simple and compound interest, so that we will study tomorrow. After that we will have a mini mock test on Friday. Okay, so that's all for today, guys. We'll meet you in the next class, that is tomorrow, same timing, 10 a.m. Till then, take care of yourself. Bye bye and study hard. Thank you, everyone. Thank you so much.